So we have the next question, number 14 up here. Now the other one that we did, 13, was a monomial times a trinomial. Well, you can see here, this one is a binomial. Remember, two terms because of the plus sign. And here we have 1, 2, 3 terms again, trinomial. So here, I'm going to draw a big rectangle that's going to have 2 by 3. You can do 2 rows and 3 columns, or vice versa, 2 columns and 3 rows. So I counted the number of terms in each of the polynomials. Now I'm going to draw that big rectangle. For me, I'm going to make this 2 rows, and I'm going to make this 3 columns. So 2 rows, remember, rows go in this direction, horizontal, columns go up and down. If you multiply the two numbers, 2 times 3, you'll get 6 individual squares. After we created our grid, remember our next step was to place the polynomials on the outside edges. So notice one side has 2 spaces, the other one has 3. Make sure you put the polynomials on the correct side where they fit the best. So of course this binomial will go here. Make sure, as always, to include the sign. And then our trinomial will go right on top. Again, see how I brought the signs down. Now we have it set up. We told you step 4 is just to fill in the individual squares. So you're going to see if you have any like bases or like letters in our case. So we got p squared and p. Remember the product rule says we add the exponents. Now we got a square here, but notice we don't have an exponent here. We talked about this. We said there's always an understood 1. So if you got 2 p's on top, 1 p to the left, that means we have 3 p's altogether. Then we're going to multiply our coefficients. We have a 7 here, but as you remember, if you don't see a coefficient here, you can slip in a 1. So 1 times 7 is 7. We're going to fill up the other individual squares. So p, 1 on top, 1 to the left. That means we got 2 of them. And then the coefficients, just multiply. Here, 1 times anything, you know it's always the other guy. So this is going to be a positive 7p. You can put the little 1 there if you want. This times this will be 4p squared. This times this, remember, p to first, no p here, still have 1 here. 1 plus 0 is still 1. And then negative 3 times positive 4 will be negative 12. And then positive 1 times positive 4, you know from your tic-tac-toe board, positive 4. Now, unlike the other problem where we only had 1 row, notice that we have 2 rows here. The reason why I like the rectangle method is because we need to collect like terms. And our like terms are where we have the same variable parts. Remember, variable part is the letter and the exponent. So notice this and this have the same variable part. What I like about this rectangle method is that you'll see like terms will line up diagonal from each other. P to the first, p to the first, these are like terms. So what do I do with like terms? Well, we skipped that step last problem, but for here you can see to collect like terms, what you want to do is keep the same variable part. So p squared was p squared will stay p squared. All we're going to do is combine those coefficients. Because we're collecting, we're going to use our tug-of-war rules. So as always, since we want our final answer in descending order, you start with the highest exponent first. So that's going to be 7p cubed. No other p cubes. Next is p squared. Remember how I said they line up diagonal? This is a negative. This is a positive. You know, when we have a negative and a positive, different signs, you're going to subtract. So 21 from 4. We're going to get 17. P squared stays p squared. But remember our sign. Who wins the tug of war? 21 players or 4 players? You know 21 will win. So it's going to be negative 17p to the squared. These two guys are like terms as well. This is a positive, you see the plus sign? This is a negative. So just like we did in the other one, different signs, subtract. Remember, keep p to the first, p to the first, still p to the first. You don't need to write that there, it's always understood to be there. So 5p and 5p to the first would be the same. And then 12 players versus 7 players. You know 12 has more players, so that means team negative wins. Make sure you have a sign here. And this is the only square that has a constant. Constant terms you're going to write last, so just bring down it as positive 4. This would be your final answer. 1, 2, 3, 4 pieces to your final answer. It doesn't matter that this was 2 terms and this was 3 terms. Your answer could have 4-term polynomial.